Hello everyone, it is time for another React lesson. Today we're going to be building React Permissions, which is a project to create permission-based routing. So one of the most common goals of a React application is to have conditional rendering based on the kind of user that is signed into our application, whether we're dispatching based off of their permissions or their role or their authenticated status or whatever. We end up writing a lot of like user is and style of code. And I really like the abstraction that React Router has with a route component, which handles that for us. So if we take a look inside of app, we're going to see we have some route components. We have a login route. We also have this fall through route, which renders this arbitrary manager component that I wrote. Did you also know you can render children within route? It's pretty cool. It wasn't super useful until recently because almost all the times you needed like the route props, but now that there are hooks for React Router, you can just render children, which I think is cool. And we also have this switch component, right? And what the switch component does is, for me when I was learning React, right, this was absolute pure magic to me. That we had this component that, right, somehow what it does is it looks through all of its children and it finds the first route component that matches, you know, the path and whatever other parameters we've given it, and then it only renders that. Right. So if we look at our application, which I already have running here, right now we're on our root, so we render this. If I were to get rid of switch, we would actually render both because it would match both our login and our root, and it's not doing that, which is the opposite of what I wanted to happen. Why aren't you doing that? Oh, it's because this is backwards. I would have to be at /login for it to render both. Yeah, so we render both when we're on /login without switch because path is going to match login and the lack of path is just going to match anything by default. So what our switch does is it prevents that from happening, and we only render one of them. And this is wonderful, and this feels like deep, dark magic because I would have no idea how to do this, right? I know how to write components, I know how to use state, I know how to talk to things over the network in React. But this was the first time I really encountered something that felt like code I couldn't write. You know, that the library developers have access to some secret tools that I do not know and I am not allowed to know. And so the code that I write is therefore inherently inferior compared to library code. And what we're going to see is we're actually going to look at the source code of this component later, and it's really not that complicated, and it's a very powerful pattern that we are going to exploit. Some of you may have also noticed that we're doing TypeScript for this project. For those of you that haven't used TypeScript before, don't worry. You can pretty much ignore all the TypeScript bits that we do. For example, this app is app.tsx instead of app.jsx or JS. Yet, you will find nothing that isn't already valid JavaScript in this file. There's no extra TypeScript bits here. TypeScript is pretty smart at inferring types and things like that. So we really don't have to write that much extra code. We'll go into the extra TypeScript bits that we have to do. And if you want to follow along in pure JavaScript, you can just not do those parts. All right. Do we have any questions before we get this kicked off?
Yeah, if your unpathed route was above the login, would that one be the one rendered?
Yes. Yeah, it goes in linear order, so this would match first. And then we would get manager here. And this is essentially the same as that. Path with an empty root slash. They'll both match everything. I'm specifically showing you this style because we're going to make our components work the exact same way. I like this pattern of the switch and then having a fall through route. I use that a lot in my React applications. So that's what we're going to be doing here.
Default break or
Yeah.
not default break, but yeah.
Yeah, exactly. And in the switch statement, this is our default case. And the reason that we really need to do this is because we don't have a switch expression, right? Like you have to return things out of switches, which makes it cumbersome to use inside of JSX. All right. So if we want to imitate React Router, we have to start at the top. So I'm going to go into my index.tsx, and we're going to look at the first step we have to do whenever we're writing React Router code, which is to import browser router as router and then wrap our app inside of this. One, I do not understand why everyone always renames this. You can just leave it named browser router. It changes nothing. But two, what this is a context provider. And for those of you learning modern React, undoubtedly you've heard of context before. But in the early stages of React Router, this was actually kind of an instance of secret library code, right? Legacy context, old style context wasn't super popular and was largely used internally or by libraries. So things like Redux could do special things. But now context is super easy to use, and we're going to be writing our own context provider. What the essence of context is it allows us to render a component like router somewhere in our React tree, and then anywhere below that component in the tree, we can access values that have been provided by the context provider. So this gets us out of the idea of linear prop passing. We can share data inside of our application without having to pass the props everywhere, which is super useful for library code, but also just useful in general because sometimes you want the whole application to be able to access certain types of data, like what are our user permissions? And so context is a great use case for that. So I'm just going to keep this down here as a source of inspiration. And we're going to go ahead and we're going to create a file called permissions.tsx. We're going to import React from React. TypeScript is going to get mad at me, but don't worry about it. So our first step for creating context is to call a function. Real quick, going to name this variable permissions with the correct number of s's. Context is equal to react.createContext. And this is fundamentally what's going on is React hides the implementation details from us, but this is all we need to get started with a context. This is going to provide us with a way to give values to our React application as well as receive them, to consume them. We use the terms provide and consume in respect to context. So the way we would provide this, so the way we would write something like router is generally we would write a wrapper component, something like permission provider. Now that context is a thing that most people know about, we tend to leave the word provider on the end of our context providers instead of just calling it router, because people know what a provider is. And so what we would do is we would return permissions context dot provider, which is a React component that accepts a single prop called value. And initially this is going to be undefined because we don't have anything yet. And what we want to do is we want to render the children that this component receives. So whenever we have a React component like router or div or whatever that has other components rendered inside of that, all that is a nice shorthand for us to assign them to a special prop named children. So I'm going to go ahead and destructure my props here and call this children, and then we would just pass those children right on through. And there we go. Except the problem is that this is TypeScript, so I need to give a type to my children. We'll talk about that in just a second. First, I'm going to give you a really quick crash course in TypeScript. You'll notice we haven't had to do anything different than normal JavaScript so far. That's because TypeScript is very smart. TypeScript is very good at inferring what the types of things are. So for example, if I say const num is equal to 4, right? And then if you look at the very bottom of my screen, and I have to keep moving back and forth on my cursor, otherwise it's gonna show me that message right there. But you'll see that the value of num is 4, right? But if I allow this variable to be reassigned, if I say let num is 4, let me just get rid of that error message real fast. We'll see that we now have let num colon number. So what this thing after the colon is a type annotation. That's TypeScript telling us that the variable num is of the type number, right? And so I can do something like say num is equal to 6, and that's fine. But if I try to do num is equal to a string, for example, TypeScript is going to complain. And it's going to say type string is not assignable to type number, right? The variable num can only hold numbers. So we have to stick with that. We can write type annotations on our own. What's happened here is that TypeScript has inferred the type of number. But I can go ahead and say that num is actually type number, or I can specify other types. For example, I could say it's type number or type string. And that's what this pipe is. You know, in JavaScript, we have the double pipe, the logical OR. We just get to use single pipes as OR in this. So now num can be a string or a number, and this line of code works just fine. So that's our very, very basics of TypeScript. Any questions there? All right, cool. Oh, one more thing. Since I don't have the Slack, if any of you have text-based questions, I do need to use the Zoom chat, which makes me very sad to have to use, but I now have that open in case you don't feel like unmuting yourself. So that's our basic TypeScript. We'll be learning a little bit more as we go along, but I need to provide a type for this component. And luckily, React has a nice helper type built in called react.fc, which is react.function component. And what that's going to do is automatically type this like a React component that expects a children prop. So we don't have to worry about that. And I'm going to go ahead and import this. I need to export this provider. Permissions provider. From permissions /permissions. And now it's going to stop complaining about some stuff and start complaining about some different things. There, that should be enough to make this stop yelling at me. No? Oh, I'm going to make this typo literally every time. I wrote permission instead of permissions. Excuse me. So let me fix that. There we go. So now this is going to work, and we can render this. I'm going to do it underneath the router. Because if we do the login stuff, we're going to need some of the history.push going on. All right, so now we have our context going. But this right now provides a value of undefined, which is not useful. What we want to do is we want to provide a more interesting value. So what I'm going to do is I'm just gonna mock out what an actual authentication system would look like. Normally you'd communicate with your backend or Auth0 or Okta or something like that, and you'd get back, you know, a token or a JSON response that contains the permissions or roles or whatever that your user has. So I'm just going to use a state variable to mock that. So I'm going to say permissions, set permissions is equal to use state. We're just going to mock up some permissions here. So user.write user colon write and user colon read. Right, those are going to be our permissions. And then I want our value to be an object that contains that permissions array. But TypeScript is now going to yell at me. And that's because when I created this context, what I did implicitly was I created a context that has a value of type undefined, which you can see at the bottom of my screen here. And what this set of angle brackets means is a generic. So we're going to have another quick TypeScript lesson. So I have an array. And this is 1, 2, and 3. And if we go look at the type of this, we see that it is number and then a set of square brackets. And that's a nice little shorthand for us to say an array of numbers. We can do other things right here. We can do an array of numbers and strings. That's totally fine. And that's great shorthand for the array. Some of you might be thinking, well, why not this? Right? That makes more sense. Well, the problem is that what this means is an array of exactly one number, right? Instead of an array of variable length of numbers. We don't have this shorthand for other values. Like if we wanted to have an object that had, certain key values and stuff, we don't have a shorthand like this. I'm sorry, certain value types. So what we instead do is we have an equivalent syntax here, which is array of numbers. That's what these square brackets mean, is that array is a type that holds something else. So it accepts a generic value here, which is the type of things inside of the array. And context is a similar type. Context accepts a generic value, which right now is undefined because TypeScript is inferring that for us, of what the value of that context is. Much like an array can hold anything, so can our create context. All right. I'll just go a little bit further and then I'll stop for questions. I'll leave this stuff here. Just comment it out. So what we want to do is we want to tell TypeScript what the type of this context is without actually providing a value here. We'll see that we can provide a value to create context, and this is going to be the default value of this context. And it is what's going to happen when we consume this context outside of the provider. It's going to be the default value. There's some different opinions on what we should do with default values. Some people like to provide a complete example so that they can use it in testing. I'm not a big fan of that because it's pretty easy to provide another instance of the context if we need to. Instead, I like the default value to be null for reasons that we'll see later, and we just have to tell TypeScript to accept another possible value for our permissions context. We're going to do that by creating a type. And I'm not going to go into super great detail. Again, this is just kind of a crash course, enough TypeScript to be dangerous. We can create the type of an object. I'm going to do it this way. By saying type, instead of const or let, we're going to call this permission context value. And this is going to be equal to an object that has a key called permissions, and its value is going to be an array of strings. And then what we can do is we can specify that generic value for the create context function. The value is either going to be permission context value or null. And now TypeScript is okay with us. And I spelled it wrong again, didn't I? I have an extra S. Gosh, I keep doing that. I'm never going to spell this word right. I should have gone with roles. I'm such an idiot. All right, so there we go. And now, nope. Did I spell it wrong again? There we go. Okay. So now we have our context value. Do we have any questions here?
Yeah, where are you exporting the permission context or the permissions provider?
Just at the bottom of my permissions.tsx file, and then I'm importing it here as a not named default import. I'm sorry, as a named import, not a default import.
Okay, perfect. Thank you.
Yeah. We're going to be exporting a bunch of stuff, so I'm not even going to do a default export.
I'm just wondering about the single pipe. Is that normally a bitwise or?
Yep. Yeah. So the reason that we don't use single pipe as the logical OR in JavaScript is the single pipe is reserved as the bitwise OR. Same thing with and, which is largely for historical reasons, that used to be used much more frequently than the logical versions. Whenever we're doing TypeScripty stuff, which is like inside of these type declarations or like these generic things, you're very specifically not allowed to do JavaScript in there. Because what happens is TypeScript checks all of the types while we're developing and while we build the React application, which eventually turns into JavaScript, where the types cease to exist. They are gone forever. So while your application is running, types are not enforced. That is purely a compile time operation. And so because we're not allowed to do JavaScript stuff in there, we can just use the single pipes because it will never be, a bitwise or a logical operation. It is very specifically just type magic.
I see.
All right, that's a good question. Any other questions? All right, cool. So now we've got our permissions set up. I'm going to do one extra thing, which is I'm going to restrict the value of permissions here. I'm going to create another type called permission. And this is going to be just some strings, user write, user read, user admin, I don't know, something. Right? This is just some arbitrary set of strings. And I'm just going to restrict the value of this to be specifically an array of permission values. Same thing with use state. I'm going to say this has to be a permission array. Right? And we use the same kind of generic here. Because TypeScript infers these to be strings, it doesn't know they're specifically permission strings, so we just have to tell it. All right. So now I want to use this context. I want to use this context. So what I'm going to do is I'm going to actually full screen this because this is not a super visually interesting lesson. We're mostly looking at code here, so we don't really need to see that login screen. I'm going to go into my manager component, and I want to use this context. So what I'm going to do is I'm going to export this. Then we're going to write some code. I'm going to import permissions context from, watch this, I can just say permissions. All right? I don't have to say ... /... permissions. And do you know why? Because of a very small thing that I will go to my grave not understanding why this isn't the default. In my tsconfig, I've set a key here called base URL to be source, src. There's a similar option for package.json. I don't remember what it is off the top of my head. But what this allows me to do is allows me to import stuff from source by just typing the name, right? The same way we resolve React from node modules, what this is going to do is it's first going to check our source folder and say, oh, does permissions exist in source? Yes. Okay, well, now you can use that. So this is wonderful, and I use it always, everywhere, all the time. Because I hate the arbitrary number of ... slashes. Okay. So I have my permission context. I can use the old style consumer, which we'll peek at later when we do look at the source code for React Router. But for now, I'm going to use the new style of consumer, which is this use context hook. So what I can do is I can say inside of my manager component, I'm going to say const permissions context is equal to use context, and then I give it my permissions context value. I'll have value under the end of this. And so what this is going to do is this is going to give us our permission context value. And if I console log this, I'm going to shorten this to PC for permissions context. If I console log this, and then go back to our root route, so we can go ahead and see that value here. We're going to see that it is indeed our object, which contains the key permissions and then the array of permission strings, which is perfect. But I'm a cool kid, right? I'm a cool kid. I love destructuring. So I'm just going to go ahead and actually destructure this real quick to permissions, right? And then change that. But now TypeScript is going to yell at me. And the reason that TypeScript has done this is because I very specifically said, right, that if we try to use this context outside of its provider, we're going to get null instead of our object with the permissions inside of it. And so that's what TypeScript is preventing me from doing, is that this could be null, so I can't destructure it. If I tried to destructure null, I would get a null pointer, dereference error, right? Cannot get, permissions of null, like that horrible cryptic error you see all the time in JavaScript. TypeScript is literally preventing that from happening. So instead, what I have to do is I have to make sure that this value isn't null. So what I can do is something super cool. This is why TypeScript is very, very powerful. I'm going to check and see if this is null. If this is specifically null, then what I'm going to do is I'm going to throw an error. I'm going to throw a new error. Must be inside of permissions provider. Right? And we're going to see something very neat happen, which is if we look at the type here of PC, we see it's either our permission context value or it's null. Right? But if I now go down here, we see that it is just permission context value. And I left out the S in that one, but whatever. I used it the same way both times, so that's fine, I guess. It can no longer be null. And that's because TypeScript is able to see, right, if this value was null, then we would throw an error, which means this function would stop running. So if we reach this line with this console log in it, therefore, permissions context cannot be null. So I can do something like this. I can do that just fine. If I put the S on there, gosh, I should have done roles. All right, so now I can destructure it because TypeScript knows. TypeScript is brilliant. All right, any questions with that? All right, cool. But this is a lot of code just to try to access our context thing. So what I'm going to do is I'm going to write a custom hook. So I'm going to declare a function here inside of our permissions file called use permissions. Right? And this is a very complicated process to create custom hooks if you haven't done it yet. So custom hooks have two rules. One is that their name starts with lowercase u's. Very important. Two, they're a function. Three, I'm bad at counting. They can use hooks inside of them. I have written a custom hook. All a custom hook is it just a function that starts with the word use that we can put other hooks inside of. So I'm going to go ahead and import use context. And then I am going to, instead of doing these things, I'm going to return our permission context value. Change this error message so it's use permissions must be inside of permissions provider. And then I will import use permissions. And then I will say const permissions is equal to use permissions. And there we go. Now I have used my custom hook. All right. And so what I could do is I could start writing the style of code that we're very, very used to seeing, which is conditional rendering, where I say something like permissions dot includes user :write. Right. If this is true, we use our AND operator and we say render this. And we could also, do a ternary here and have a fallback case. But we would do something like this. Right, and so this would work because our default user has user.write. I'll just take that out real fast. and we'll see that now our delete button no longer renders. And that is perfectly fine, and you'll still write this style of code a lot. However, I do really, really, really like the React Router way of handling this, right? Of being able to use JSX to control this piece of rendering, because this can get ugly, this can get complicated, especially with switch, right? I alluded to earlier, switch is not an expression, and in JavaScript, we have to return out of it or mutate values. So we have no easy way of handling kind of multiple cases where we only want one thing to happen. So you would end up writing like a chain of ternaries that like slowly nest their way to the right. And that is terrible code, which I'd never pass code review, even though I do that. I use so many ternaries, no one can stop me. So what I would do is I would really like to, I'm gonna fantasize here. I'm gonna write a component that does not exist yet. I'm gonna call it can, because I don't have a better name for it. And this is gonna be my equivalent to route. And instead of a path, it's gonna take permissions, and we're gonna say user.write. And the idea here is that can will only render this button if the user has these permissions. Okay, and we'll import our non-existent can from permissions, because eventually we're going to do this correctly, and then TypeScript will stop yelling at us. So I'm going to pop on back to permissions, and we are going to write can. Taking some children, right? And ultimately we're going to return those children. I'm going to put them inside of a fragment, because sometimes TypeScript yells at me about children, and I don't know why, but this fixes it. Okay. So here's our can. It's of type React.function component. In this case, we're going to need props. And so the way we're going to do that is by giving this generic value of p, this generic value of props, to React.fc, React.function components. And instead of using a type, right, we're going to write an interface. What is the difference? Honestly, I don't know. There are some differences. An interface is basically like a default object type. It can also extend other types, and it does some special things, I'm sure. But I'm just going to use it instead of type, which I did up here, just so you can see it both ways. But it works essentially the same. Just going to go ahead and actually copy that. Boom. Now we have an object type of can props, which has a key called permissions and a value, which is a permission array, except I'm going to change this slightly. I want to emulate the exact interface that React Router has here, where this can be an individual string or an array of strings, or we don't even have to supply it. Yep, undefined. Right. We have a nice little shortcut in TypeScript where if this isn't required, right, if it can be undefined, then I can just put a question mark right here. And that will automatically allow this prop, this key, to be undefined. So I can just give this as our generic value to React.function component. And now I also have access to permissions. All right, and so what I want to do is I want to write some logic that determines whether or not we should render our children. So if match is true, then I'm going to render my children. Otherwise, I am not. I'm going to return null. So let's write this logic real fast. What I want to do, right, because I've instantly complicated this for myself. Permissions can be a string, an array of strings, or undefined. I want to write my validating code as if it's always going to be an array. So I just really quickly have to make sure it's an array. So what I'm going to do is I'm going to use a default value here. So if permissions would be undefined, now it's an empty array. Pretty cool. So now if I check the value of permissions, TypeScript is going to be smart enough to know that this is either a string or an array of strings. So I am just going to say permissions array is equal to if array dot is array of permissions. So if permissions is an array, then it's good to go. If it's not, then I'm going to put it into an array. So boom, now this thing's type is permission array. Right? It is guaranteed to be permission array, which is pretty cool. So I'm going to say is if permissions array dot length is equal to 0. If it's empty, then match is true. This is the same behavior of React Router, right? If we look in our app, right, this empty route will always match. So I want to emulate that behavior. So if permissions array is empty, we have a match. Otherwise, what I want to say is, I shouldn't have gotten rid of this so quickly. So in our app, this value for path can actually be an array. I don't know how many of you know this. It's not well advertised in the docs, but we can actually do things like this. And now this same route, the same login component, will render on /login or /signup. Right? If any of those match, then we can render this route. So I'm going to emulate that behavior. And maybe we eventually want to write a prop that allows you to toggle like or and. Does the user need all of the positions or permissions or just one of them? I don't know. You can change it. A nice thing about writing this code ourselves rather than using some kind of library is we don't have to make it crazy configurable because we can just change the code. So I'm going to say is if permissions array, if some item in this array is inside of our user's permissions, then we want to set our match equal to that. Well, now we need access to our user permissions. Well, luckily, I already wrote the hook for this. So I can say const permissions is equal to use permissions. Except I've already used the word permissions like 12 times, so I'm just real quickly going to rename this to user permissions. Whew. So now I'm going to check if user permissions includes P. Right, so now what I've done is I've taken this code and I have abstracted it away into my component. All right, so here's my matching code, and then here is where I decide whether or not to render my children. All right, any questions with this? All right, cool. Yeah, so for those of you that don't know, sum is the exact same as the find method, but it just returns true or false. Find returns the actual thing that it found, and I don't want that because empty strings are falsy, and that could be a bug, so we're not doing that. Okay, so now what I can do is just save this again to make sure it works, and I'm going to go back and give our default user right again, and we'll see that we have 2 buttons. Incredible. And that's because our can component works exactly the way we wanted it to. So I can go ahead and get rid of this code. And now, now I have this button that will only render if I have permissions to use that action that it describes. Oh, did I use a double equals somewhere? Thank you, React Linter. I would hate to use double equals. Where did I do this? Oh, that should be triple equals. So remember that front-end security is just user experience, right? Your API should be verifying user permissions before you allow them to delete anything. But we don't want to render the delete button if it's just going to throw errors, right? So front-end security, this kind of stuff is just for good user experience. You shouldn't actually use it to protect anything because it doesn't work. Because they can just call the API. All right, cool. So now we have our can component. So now I want to build switch, and we can double check that this works with an array, and it will because I'm a amazing coder. Now I want to build switch, and in this contrived application, I don't have a compelling reason to use switch right now. I do it at work all the time, but this is not a complicated application, so we're just going to build switch because we can. So what switch does, let's go ahead and look at app.tsx. What switch does is somehow it inspects the child components that it is given. It finds a route, checks to see if it matches, and then only renders the first route that matches. So if we didn't know any better, right, from most of our React experience, that seems to be an impossible task, right? How could it do that? How could it possibly do that? And if you start thinking to yourself, well, how could this library do that? I have no idea how it only renders one of its children. Do you know what you should do? You should read the code, right? React Router is open source software, and that means more than us just being able to install it via npm and then use it for free. What that also means is that the source is available for us to read and for us to contribute to and learn from. So this is literally just the React Router GitHub, and this is how I learned how to do this some number of weeks ago, as I was like, how do I do the switch thing? I want to do the switch thing, but for permissions. So I went here, and if we go into packages, and we go into React Router, and we click on switch.js, we'll see that this is not the right switch.js, and that it is actually inside of modules for some reason. And then we look at this switch.js, we'll see this is the real switch component that React Router uses to do all that deep dark magic. That's it. It's very short. It's a very short component. So we can just read it. It's a class-based component, right? You could use a functional component for this now, but why fix code that isn't broken? It uses the old style of context consumer, where context.consumer is a component that accepts a render child, a function child, right? So we would use our use context. This is just the same code we have with use permissions. It's doing the same thing we did with throwing the error if it's null. That's all this invariant is. And then what it's doing is it's using a function called react.children.forEach. So if you weren't previously aware, React has built-in functions for us to manipulate child components as well as map over them, turn them into arrays, perform operations on each of them. And if you Google React children, you'll find the React documentation for this, which, as always, is pretty dang good. So we have a couple functions here: map, for each, count, only, and toArray. And there's some wonderful logic or knowledge in here that you wouldn't actually just get from reading this and trying to do this on their own. So if you were a cool functional programmer, you would use react.children.toArray.find to find the first matching component. But that's actually slightly incorrect because the map method and the toArray method will automatically set key values for all of those children, which can cause components to remount. If you're rendering the same thing in two different places, it'll automatically now get two different key values, and you'll cause this component to remount, which isn't what we want. Which does not matter here, as we are not doing expensive production-y things where remounting it is a performance issue, but it's good to know. And this is the kind of intricate, useful lesson that you can learn from reading other people's code. reading other people's code is never emphasized enough in coding education, partly because it's really boring and difficult. But that's where you're going to learn possibly your most valuable lessons, is whenever you're like, I wonder how this works. Well, you as a developer are equipped with all the tools you need to understand it. The code is right there on GitHub. Go take a look, figure out how it works, and fix a bug and contribute to it and put it on your resume. You too can be the next Michael Jackson, who is one of the maintainers of React Router. Okay, so we're going to use react.children.forEach. We're going to do a very similar thing to them. I am not going to copy and paste this code. One, because don't do that. Write it yourself, learn things. Two, that's illegal. This code is open source, but it is licensed under the MIT license, which means we do need to give attribution to this code if we were to use it in that way. I'm going to look away from this and provide a clean room implementation of our code, although probably a good idea to include a reference to this if this were serious software. But I'm not going to do that. So what we're going to do is we're going to come back here and we're going to write switch. So export const switch. I'm just going to call it switch2 react.fc because it just needs children, no other props. Oop. Okay. And that's an extra equal sign. Okay. So what we're going to do is first we're going to use our context. So I'm going to get my user permissions, rename it user permissions because I use that name too many times. Use permissions. All right, so now I have my context value. And then I'm going to do a similar thing. I'm going to say let our element be a React node, which is any value that is a React.React node. That's any value that can be rendered into a React document. So null, a number, a React component, an array of any of those things. This is actually the type that children is React.React node. And you can see if I hover it over it, it's various React element types, and then also an array of those things, or null, or undefined, or a portal. Do you guys know what portals are? I'll do a lesson on those later, but portals are crazy. And null is one of those valid values. Then I'm also going to say match is equal to false. So what we're going to do is we're going to say react.children.forEach for each one of these children. I want to take one of the childs, and I want to check and see if it matches. So first we're going to do a little bit of housekeeping. We're going to check and see. We're only going to do this if our child hasn't matched yet, and this is a valid child. Is a valid element. So this is a helper function that React includes, which is going to filter the possible React nodes to no longer include undefined, null, or the node array. So this will only be true in the case that this is a React component that accepts props, which means, thanks to TypeScript's wonderful type inference, which means that if I do child dot, I can see the three values that this object can have. It can have a key, it can have props, and it also has a type, which is the type of the element that this is. If we look at the React router code, they do something that I think is really interesting here. They use something called duck typing. And what that means is if it looks like a duck and quacks like a duck, then if it walks like a duck and quacks like a duck, then it's probably a duck. So they're just checking to see, do the props of this children include path or include from? If so, check and see if its path matches. And this is a wonderful bit of code here, because this is what allows us to do things like write a private route component that extends route, and have it still work with inside switch, because all switch cares about is that you have a path or a from prop. We could do that here. I am not going to do that because, one, I want a little bit of additional type safety, and two is that, again, we're not writing a library, we're writing our own code, so if we want, we can always just go change this later. So we're not going to be quite as elegant because we can just change the code. So what I'm going to do is I'm going to check if the child dot type is equal to can. And so what this will do is this will check and see if the element that we're trying to render here is one of our can components. Only then will we proceed. So what I'm going to do is I'm going to set the value of element to be our current child. And then I want to check and see if this matches, right? Ideally, I would have like a check match function, which takes my user permissions, and then also the props of my child element. But check match doesn't exist. However, I have made a wish. I have presumed that I have a function that looks like this. So now I'm going to write it. And I'm going to do that by just taking all this logic from can. So I'm going to create a function called checkmatch. It's going to take 2 arguments, which I'm going to type. I'm just going to type the arguments directly. So it's going to take user permissions. And I specify the type with the type annotation by just saying a colon and then the name of the type, which is going to be permission array. And then it's going to accept another value, which is our can props, which is of type can props. Because I can just use that type again. And then I am going to steal all of this code and put it right in here. I'm gonna have to destructure. Whew, was a deep pull from can props to get my permissions. And then at the end of this, I will return match. So now what I can do is I can instead say match is equal to check match. I will give it my user permissions, and then I'll also give it my props, which is going to mean that I'm going to need to instead destructure on line 1 so that I have access to the actual props here. And there we go. And actually, it turns out I don't access permissions directly inside this anymore, so I didn't even have to destructure that. And so now I can reuse that here, which I do successfully because I willed it into existence. We actually there's a special thing that's happening here that violates our type safety, which is that technically child.props has any value. Right? If I do dot permissions, we're going to see that the type that TypeScript gives it is any. And the thing that's happening here is that, well, we do have a guarantee when trying to use can that we don't give it bad props, right? Now TypeScript's mad, is that we can actually override these at any point. I'm not going to use this here, again, because we're not writing high-quality production code. But there's this function, react.cloneElement, that allows us to take any element that we're trying to render and just change the value of its props or its key or its children. And this is not type safe. So technically, we could give this child any props that we want. So TypeScript doesn't know. However, we have a pretty good guarantee that that is the case. And what TypeScript allows us to do is it allows us to just tell it what's up. So I can say, you know what, actually, these child props, they are can props. I can just say these child props as can props, and then TypeScript will listen to me, and it will allow me to use these props as if they were can props. So now .permissions is correctly typed and auto-completed for me. Yes, so there is my match. Now when I get down to the bottom, I want to return. If our match is true, I'll return the element. Otherwise, you get null. And there we go. Now we have our switch, right? It's a pretty small amount of code. This check match had to be a function rather than a hook because we can't call hooks conditionally. I can't use a hook in a loop, so it just has to be a function, and we have to give it user permissions, and it's not a big deal. But yeah, so let's test this out. So we're going to add a switch here, right? And I'm going to just rename this as permissions switch just to prevent confusion. Permissions switch. And then so we'll have a fall through here, which makes no sense, but it's fine, called view. Right? So if our user doesn't have write permissions, then they're going to end up seeing a button that says view. And we'll make sure that our default user first has the write permissions. Nope. Uh-oh. Uh-oh, TypeScript. Where did I do it wrong? Oh, it's because I forgot that. I have to make sure this is not undefined. That if it is undefined, it becomes an array instead. Okay. So now we see this delete button because our user has delete permissions. But if I go ahead and change my user permissions, and I built the login page so that you could log into different users and have this happen, but this is faster. So if I delete the user write, now switch is going to fall through, and we're only going to see this view. And I could copy and paste this again, and we're not going to see two view buttons. Incredible. What incredible magic has happened. We've written a very, very cool component with permission switch. Do we have any questions at this point?
Yeah, the something as can props. That's how you cast in JavaScript.
Yeah, that is casting in TypeScript. I'm just saying that this type is can props, and you can only cast down, right? Like if I can't say like undefined as true. That is not allowed because undefined can't be true. Child.props is of type any, which is a special TypeScript type, which means it can have any value, which is the type that everything in normal JavaScript is. So we can do that. You can do undefined as unknown as true, which will let you cast into anything. Unknown is another special type, which is, I don't know what it is.
Also, I didn't see where we get to the fall through can. I was trying to keep up with coding and seeing some errors. So.
Okay. Yeah, so this is a pretty tricky bit of logic that I did here. So the way that our check match function works is we have a special case where if the length of the permissions we're given is 0, if no permissions were given, then we automatically make that match true. And we also do a little bit here where we make sure the value of permissions array is always an array, so we don't have to worry about handling the various possible cases of it being a string or undefined from here on in the function. And we do this by setting the default value to be an empty array, right? So if permissions was undefined, now it is an array. And then I use a ternary here. If permissions is an array, then it's fine. Otherwise, we just make it a one element array so that we can use this same logic on it. Does that make sense?
Yeah, okay, so if we match one of the permissions, right?
Yeah.
Permissions equals something, user, right? Okay, then we're gonna render that.
Yes.
But if we have nothing, just an empty array, then let's see. So if it's 0, match equals true. Okay.
Yeah. Yeah. So if it's of length 0, if we have no permissions, then we just automatically let it through. We don't even check these.
I see. Yes. Okay. Thanks.
Oh, no problem. All right. Any other questions? Did a lot of stuff pretty quickly here. Now we're all feeling good with this. I'll clean some of that up. All right. Is there anything else that you all would like to see? I had some stretch goals here that we could do, like write a private route component. I'm not going to integrate this with an actual authentication system. We did. Oh, you could write a switch that works for both private routes with our can logic in them and other stuff. I don't know. Anything else y'all would like to see? Any questions?
Yeah, sorry. There's another one about the array when you were declaring it above. I didn't quite follow the. Suppose you wanted an array that could hold any kind of value, like a JavaScript array.
Mm-hmm.
How would you do that with TypeScript?
Yeah. So it depends exactly what kind of array that we want. So we can use the any type. I can say const array is of type any array. Is equal to 1, 2, 5 string empty object. And TypeScript is more than happy to do this. But the problem is we should really avoid any when writing TypeScript whenever possible, because what this means is I can do array.map some element, and then element does not exist. And TypeScript won't stop me because element has any type, so I can do whatever I want to it. And so that is bad. Instead, what we can do is use the unknown type, which says, listen, I don't know what type is in here, but I also don't care. The important thing is that this is an array of things. Unknown. And TypeScript will not let me do things on unknown types unless I clarify, its type, either via assertions, which is what this throwing an error is this is a type guard. So I'm saying that this specifically is no longer null. Or I could do the same thing, asserting that it is, an array or an object or a number or something else. And then there is another way, which is using generics. So for example, our little line of code here could be a function called coerce array. So I could write a function called coerce array. And what this does is it accepts some value x, and it is going to return an array. So what I'm going to do is if x is an array, then I'll return x. Otherwise, I'll return an array of x. Right? But I don't actually know the type of x. And I could say it's unknown because I don't actually care. The problem is that now my return type is in any array, right? We know it's an array, but we don't know what's inside of it. So instead, I can write a function that uses a generic. So I can say that this function has a generic property t, and x is of type t, or it's an array of t. And the way that we type return values of functions is I just put a type annotation right after the argument declarations. So this returns necessarily an array of type t. And so now we know that the value of x is a t array. So if I did something like coerce array of 4, we know that the result of this function is a number array, right? Because TypeScript is smart enough to go out and get the value of that generic for us. So those are kind of the three things. We can use any, which is dangerous because TypeScript won't let us stop from shooting ourselves in the foot. We can use unknown, which means we don't care about the type, but that also means we can't do things to it unless we know what the type is through some other means. Or we can use generics, which means it can be any type, but we do have to specify that type at some point.
Okay, yeah. I don't want to hog all the time. I was wondering, like, is there something where you can add to the types? Like, if you go through the array and say, well, what are the types in here? There's a 4, there's a string, etc. So you add to the types that are known?
Yeah, so you could do that with a function that would take, for example, an unknown array and then use assertions to determine the types of the elements and then return an array with that type. TypeScript, again, is also pretty smart. So I can say like num array is equal to 1, 2, 3, and then I can say string array is equal to num array.map and dot toString. And then like now this knows it's an array of strings. So we can do operations on things to change their types or, further know their types. Yeah. There's also cool things. Something you wouldn't be able to do is change the type of an array at runtime. And TypeScript types are purely compile time operation. We can't actually know things about the types of stuff once we're running. So if you get an array back, from the server, you can't know stuff about its types without doing like these kinds of types assertions. Right? But there are libraries like IOTS or Zod, I think is what it's called, that let us use kind of type checking during runtime, which are very cool things, and I think pretty essential to using TypeScript in production. Yeah. Cool.
Is this the kind of stuff that you've been like doing at work recently?
Yeah. I wrote a permissions router a couple weeks ago, and have been refining it, and it's pretty nice. Yeah, we're full stack TypeScript at work, so we use a lot of IOTS and other things to make sure that everything is type safe, which is a very nice assurance. Also use a lot of context. Context is cool. All right. Any questions? Any things you'd like to know? We went fairly fast today. I'm happy to wrap things up if that was everything people wanted to know, but I just want to make sure we're good. I can also kill the recording if you all would like to chat.
Yeah, I mostly don't want to quiz you about personal details. Also, this is on YouTube.
Okay.
So.
Yeah. So I'll stop recording. Thank you everyone watching this on other platforms, and I will see you later.